Hello, Fast Hippie here tonight. I will be talking about Nerf gun physics. I have been into Nerf guns recently and into modding, and I just kind of wanted to explore why certain modding techs have different impacts on your guns. And I was using some of my knowledge of physics and some of my own research to gain an understanding and insight into what you can do to make your gun more effective at delivering force to your dart. I will definitely do not consider myself a physicist. I am an engineer, so I will be taking the science of physics, making broad assumptions, and basically using it as a blunt tool to my own end. So all physicists watching this may want to cover their eyes and ears as I kind of ruin things, but we'll make some assumptions and learn some things as we go. So the first thing I will be talking about is the K constant. Now, springs that you can buy, especially with modding, come in different Ks. I guess the most popular and well known is the K26 spring. Essentially, K is a measurement of the force per distance. So basically how much force it takes to compress a spring a certain distance. We are talking about compression springs for the most part when we talk about Nerf guns. A higher K relates to a higher amount of force that is required to compress the spring. This K factor, this spring, actually then converts to a speed as related below. So basically, the higher the spring, the more velocity V that you can impart to the. Now, there's going to be some other things that occur, such as you probably won't impart all of your speed because the dart will probably leave the barrel before all of the force can be applied to the dart. But essentially speaking, the K factor has a square root effect on the speed, which means that if you get a K that is 4 times the amount, you're only going to impart double the speed. And so that's why often when you increase the K, there is sort of a diminishing returns, where if you double the K, you get a diminishing return when you double it, and the amount of force that you have to put into the spring is going to be also affected. So the more K, the more force you have to put into it to actually pull the dart back, but you only get a square root effect on the velocity you can impart to the spring. On the opposite end, what we do see and what this equation reveals is that the amount of compression, or the delta X, the distance that you apply the force, has a direct relationship to the amount of speed that you can apply to the dart. So if you can somehow lengthen the spring and still get it to catch, you can actually get a much more impactful impact to the speed of the dart, and then you can the K factor. This is often limited by the internals of the gun and how you can design your spring. But what this does show is that the distance and the length of the string actually has a much larger effect than the actual K factor of the spring. And so in many cases it is more impactful to increase the length of the spring than it is to increase the K factor. Then the second thing I'd like to talk about is reverse plungers. Now, in the Nerf community, we often call this dead space. And people will say, oh, if you use a direct plunger, you have less dead space than a reverse plunger. And they say that this dead space is what actually is decreasing the force you can impart to the dart. And what this really comes down to is a physics law that we call the ideal gas law, which is pressure times volume equals nRT. T is temperature, R is a constant, and N is related to the number of moles or the amount of gas that you have. And so when we have a plunger, normally your temperature, your R value is a constant, and the number of moles isn't changing. And so we can actually relate the change in pressure directly to the change in volume as shown here below, or the amount of pressure that you get, is related to the initial volume divided by the final volume. And so what that means is, if we look at our picture here to the right, in a reverse plunger, our initial volume with the plunger pulled back is 2, because essentially the reverse plunger is essentially a double of the plunger that it goes around. And the final volume is 1, which means we only can double our pressure by using a reverse plunger of equal volume. But if we have a direct plunger, as we show above, when the plunger is pulled back, we have a volume of 1, and when the plunger is all the way closed, you only have that little gap in front of the dart, which is the dead space. And so in this case, we're going to consider that little gap to be 1/10 the volume as it was initially, which means we can actually increase our pressure 10 times with the same motion or the same distance closed by the plunger. This is why that a direct plunger has much more impact and can get much more speed on the dart than a reverse plunger, because what you're doing is you're actually effectively reducing the volume much greater with a direct plunger than you are with a reverse plunger. Now, if you wanted to get similar performance out of a reverse plunger, one of the simplest things you could do is actually to fill the volume inside of the plunger, so that when the reverse plunger is all the way closed, you only have a small gap of air in the middle of the plunger that it closes onto, and again increasing your pressure 10 times fold, basically creating your final volume is maybe 1/10 of the volume with it pulled back. So that's the easiest way to do this. This can be done, I've seen, with a simple fill. I think there's something that they use for concrete fill. It's basically a foam rod that you can stick into there and then drill a hole in it. And that is a way that you can basically get similar performance to a direct plunger by filling in that dead space of your reverse plunger. Now, this dead space can have a great impact. You know, when we talk about these AR systems essentially are increased dead space as you go from one dart to the next, which is why you sometimes see a decrease in your speed of your dart as you go to further and further darts of an AR. Now, that space isn't hugely different in terms of volume, but when we think of the difference between when that plunger is already closed, that volume is very, very small in a direct plunger. So if you double that volume, then that doubling that volume would half the pressure increase. So you go from 0.1 to 0.2, now you have half the pressure that you're applying to the dart, and so on. So even that small change, like we see in AR, can have a significant impact to the dart speed. And so by getting rid of as much of the dead space as you can and making it so that the air is directly being squeezed as much out as you possibly can, you can greatly increase the pressure and ultimately the speed of the dart coming out of your gun. The last thing I wanted to talk about today is related to basically what we see here on the right. So for elite guns, you can actually get these barrels that can go into your mega barrels, and allow that gun to shoot elite darts. And what we see is a great increase in performance by shooting those elite darts out of a mega barrel. And the reason is that we are actually reducing the volume of the barrel that the air from the plunger is being pushed through. And what happens is the radius of the mega to the radius of the elite is probably half as much. And what happens is when you reduce the radius by half, you actually increase the volume of air traveling through it by 4 times. So you can actually have effectively a 4 times increase of the volumetric flow of the air going through. Now, there are many things going on here. The air, you won't get exactly that effect, because since you increase the speed, the dart quickly leaves the barrel and you won't get the full impact of reducing that. This is why sometimes when you see people that'll put a barrel, and they'll put a very long barrel on the end of a Nerf gun, and this allows you to get more of the plunger volume change impacted to the dart before the dart leaves the gun. But in any case, what's important here to see is that if you have a plunger that is much wider, or if you have a cylinder that's much narrower, you can have a squared effect on the volumetric flow and essentially the speed of your projectile leaving your gun. So the major takeaways I wanted to kind of bring in today is that the length of the spring can have a much greater impact than the K force of your spring. Now, although it's great to increase your K, sometimes it is easier just to increase the length of your spring, and that length has a one-to-one relationship where increasing the K has a square root effect, which means that if I can double the, I have to increase my K force by 4 to get the same effect. Now, often this is limited by the gun internals, but this is something to keep in mind when you're thinking about the force of your spring and how the spring works. The second takeaway here is that you want to get rid of your dead space. This is something that a lot of modders know, and a lot of people that work with Nerf gunners know. If you reduce the volume of when the plunger is already forward, and you can reduce as much of the volume as you can, so that all of the volume is just when you're pulling that back, you can greatly increase the pressure that's applied to your dart, and that pressure will basically essentially be converted to speed of the dart leaving. So by reducing dead space within your gun, you can greatly increase the pressure applied to the dart, which means you can greatly increase the dart speed. And then the last takeaway is understanding the relationship between your barrel diameter and your plunger diameter. If your plunger diameter is very wide and your barrel is very narrow, you can have a squared effect on the volumetric flow that's going through there, and essentially a squared effect on the speed of your dart. This is why rebarreling from Mega to Elite can so greatly impact the speed of your dart leaving your gun. So these are my major takeaways here. Take it as you will. I hope this was informative and helpful to those that do modding, that you can not only understand more deeply why these effects are happening to your gun. Many modders already know to get rid of dead space. Many modders know to increase the length of your spring. Many modders know to shrink the barrel, and then many have done Mega to Elite. But I hope this provides insight to why these have these effects, and so that you can really think about when you're working on these guns, how can you use these tools, these equations to your favor to really get the most out of what you have.